Go.
Okay. Hi, Craig. This is Sam Benson from Aprovetro, showing you how to use the mixing manifold for the zero gas that we use during the zero bias checks and the zero drift checks of the gas analyzer, of the LEMS gas analyzer. What we're looking at right now, just a few things out of the way. What we're looking at right now is the tank of oxygen, and the tank of nitrogen will come back. We're looking at a regulator that's attached to the oxygen tank. And we're looking at a regulator that's set off to the side that will later be connected to the nitrogen tank. So to do this bias check, the first thing we do is, let's go over here. The first thing we do is turn on the sensor box, turn on the gas analyzer, and collect ambient air. So this is a plot of carbon monoxide and time. There's time and carbon monoxide. The first thing we do is turn on the sensor box and let it collect ambient air. The next thing we do is collect zero gas. So now we're going to go and look and see how we collect zero gas. So we have a special wrench that's used to open these cylinders. So the first thing to do is to keep the valve closed. There's a shut-off valve here. This is a ball valve that shuts off the flow. And this is the regulator. And the first thing to do is to loosen this regulator so it's loose. That means that it's closed. We put the wrench on, and these will be secured. So we put the wrench on, and see these are both reading 0. We open this up. It doesn't need to be open very much. We're not using very much gas. But yeah, so right now we're collecting the ambient air, and the other thing I've drawn here is this is the beginning of a stove test. So this is the highest frequency that you can do this is before and after every stove test. That would be the highest frequency. And so what I've drawn here is we're collecting, CO, so we're collecting ambient air. Next thing we're going to do is turn on these tanks, and we're going to get this 0 point. And then after that, we're going to turn off the zero gas tanks. We're going to turn on the little tank, and we're going to plug it in, and then the CO reading is going to go up. Like I said, it's going to go not to 500, it's going to go to 300 because we're using the small tank. It'll go up to 300, and then we'll turn it off, and we'll go back to ambient, and we'll let it 0. If you're doing this right before a stove test, it's really important that you wait about 20 minutes so that the CO cell goes all the way back down to its 0 reading, because it takes a while to go back to its exact 0 point. So this is what you'd see during a stove test. You would go back down to 0, and then you'd start to get an actual reading. All right, so we're collecting the ambient. So let's maybe follow me over here and see if you can. Can you follow me?
Okay.
So now we're reading, and we're reading from inside the duct right now. That's okay. It's and we're just looking to see that the CO and the CO2 are stable, because I only put CO on the graph, but we're doing CO and CO2 at the same time. We're checking the 0 point of CO and CO2 at the same time. And so I've left CO and CO2 in green, and then the CO in yellow. Just so you know, these spikes are just kind of the way the LEMS works. The best way to deal with that is to press Do Not Cache Data, and now they're gone. It's not real. It's just an artifact of the software. All right, so we got ambient air and it's flat. So we're ready to go with the actual zero gas. Because we're expecting the CO to be zero already. We're not expecting to see any change for that, but for CO2 we're expecting to see a change.
So the CO2 is at 1.
The CO2, yeah. So I can make that an actual ppm reading. Let me make sure here. So yeah, that's a ppm reading.
It's by ppm.
So right now the CO2 it's actually telling us that the computer thinks that our sensors are saying that CO2 is at 1,000.
Okay.
That's actually not too bad, but it's probably too high. We're gonna see what happens. All right. So then I've got my this is our gas analyzer. Any instrument, there's an inlet, and what I'm doing here is I've got I've got a fitting. I made a fitting to go with this. So it's over here now, and so we got this fitting. I put this together for just for our instrument. So what we need to do is we need to do this at a positive pressure, and so we're going to use this. We're going to use this sensor. It's a pressure sensor. We're going to use that to measure the pressure of this system as we're using it. So put those fittings in so it plug together like that. And then the next thing we're going to do is plug in the sample over here. You don't need to worry about this valve; it's for another purpose. And then now we're drawing through here. We're actually drawing through there. The gauge is actually measuring a negative pressure right now because we actually put a vacuum on it. But that's okay. We'll just leave it at that because so we just need a positive reading. So it's registering a negative pressure right now. So the next thing we do is walk over here, and we're going to that zero gas. See if we can figure out a good way to get it in there. Okay, so for this, the zero gas, we need a reference point for CO and CO2. In order for the CO sensor to work, it needs to be exposed to oxygen. The CO2 sensor, you can do it with pure nitrogen, but you can't do the CO sensor with pure nitrogen because it needs oxygen in it to work. So that's why we ended up with these two big cylinders, two big regulators, mixing manifold, flow rate measurement. All these things go together so that you can end up with a zero gas that works for both sensors. We got this, we're gonna open this, it should already be open. Yeah, so this is open. This cylinder is, it's 10,000 kPa. So we're at 10,000 kPa right now from that gauge. We'll go ahead and open this one too. Make sure this is loose. We don't need it to. That one's set already, but so yeah, let's open this guy up. Alright, so we just pressurized that. So yeah, that's 1,500 kPa. 15,000 kPa. Okay. So those two are both, these valves are open now, so this is at high pressure and this is at high pressure. This regulator is already set to a fine value. That's set to a fine value. It's not really necessary to go that high, but just because you're stressing these connections more than is necessary. So I'm going to turn that down once we get going. So we'll start with the nitrogen, and we're just making an air mixture. So we're making an air mixture. So we open up this the shutoff valve, and all that happened was it just pressurized this section. Then we open up the metering valve, and we okay. So now we need to actually getting a flow rate, but to make it more consistent, let's set it up to let's set that to I think 100 is good. just keep it low. There's no reason to, as long as the regulator can handle it. This wasn't open all the way. Okay, so that wasn't open all the way. Let's get this. I think 100's good. Alright, so that's at 100. Open that up. Now we're using this needle valve to meter how much gas can come out. We're just trying to make an air mixture. It doesn't have to be exact. The only thing you really need to know is that the amount of, we can measure this later, but the amount of gas that's the flow rate through this is, it's about 4.5 liters per minute. So that means for 80%, that means for 80% nitrogen, what we want